Good day to all. Myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering. Today we discussed about physiologic modeling for experimental analysis. In previous videos, we discussed about the need of project work, how to do experiments for project work. Similarly, how do we analyze the experimental data with the design of experiment concepts. Likewise, we discussed. In this class, we discussed about artificial intelligence techniques for experimental analysis. Okay, the main aim of this presentation is used to how to reduce the experimental run and experimental cost. Similarly, many of the researchers were used to trial and error based experimental analysis. This induces many cost increment. It increases the experimental time and the associated cost also. So that some researchers were used to design of experiment concepts for developing experimental plan through factorial design. These techniques were used to reduce the cost and time of experiment. Unfortunately, this also increases the cost and the time of the experiment. So this tries further reduction on the experimental time and the cost by using artificial intelligence techniques, which is one of the which is physiologic concepts, because the main limitation of manufacturing industries has to produce the component with high quality with the minimum effort required for latest materials. So, physiologic procedure always follows the following five steps, which are defining membership function is the first step, evaluation of fuzzy rule is the second step, then universe partitioning, subsequently making a relationship between input and output membership function. Finally, it deals with the rules combination. Okay. For explaining this physiologic procedure, I applies drilling experiment. So, in drilling experiment, there are input parameters and the output responses are available. Input parameters are spindle speed and the feed rate. Similarly, output responses are thrust force required to operate the hole making operation, and also the surface finish for uh, workpiece quality improvement. In that explanation, I utilize the thrust force only. Generally, you know about what is meant by thrust force. Thrust force is the resistive force against the tool feed rate, okay, which is the phenomena available with the thrust force. If I increase the spindle speed, what happens against thrust force? Likewise, studies are important before conducting the physiologic analysis. Okay, then defining membership function is the first step with the physiologic modeling. So that defining membership function is classified into two major things, which are input function and the output function. Here, I consider the spindle speed as the input function and the thrust force as the output function. So, how do I define this membership function with the triangular function? And also, the membership function may have trapezoidal, square, likewise, lot of models available. In that, I utilize triangular function only, okay, because I consider low level, medium level, and high level of input parameters. Similarly, low level and medium level and high level of output parameters also. So that I classify the membership function like this slide. Okay. After that, evaluation of fuzzy rule. This is general. What is fuzzy rule? Fuzzy rules are developed in linguistic terms that address the relationship between the inputs and the outputs from a system. Okay, the data collected from the experiments ordered in a logic control system, which means if rules, then rules, unrules, or rules. Likewise, I may ordering the experimental data, which is logic control system. After that, evaluation of fuzzy rule always follows in this drilling experiment. Input parameter considered is spindle speed and the output response is thrust force, what I already told. The input measuring parameter is divided into three membership function, because defining the membership function is the initial step a physiologic operator. So that the input parameters is divided into three membership function called low, medium, and high. The output also divided into three sets like low, medium, and high. So fuzzy expression can be classified with respect to this table. Input as spindle speed, in that there are low, medium, and high input parameters. And also for output here, I consider thrust force, so that low, medium, and high parameters are available with my fuzzy expression. After that, evaluation of fuzzy rule. According to this experiment, fuzzy rules note down in the form of if and then rules, and also connect the input membership function to output membership function. How? For machining time, for thrust force. Machining time is also one of the input parameter. In this experiment, I consider the thrust force. So, for thrust force, rule 1, I framed the rule 1 according to my knowledge with the experience. The rule 1, if spindle speed is high, then thrust force is low. After that, rule 2, I framed like if spindle speed is medium, then thrust force is medium. Rule 3 is if spindle speed is low, then thrust force is high. Likewise, I evaluate the fuzzy rule according to my knowledge associated with the drilling experiments. After that, universe partitioning of input function. Okay, what is that? I consider triangular function for defining the membership function. So that I draw the membership function xy axis. After that, I draw the triangular functions like this. Okay. After that, I allot the parameter values low, medium, high. After I fixing the low, medium, high according to this sketch, I define the membership function with the 0, 1, 2, 3, 4. Likewise, I arrange the universe partitioning value according to the triangular function like this sketch. After that, in y-axis, I consider 0 to 1. So that I divide that into 0, 0.5. After that, 1. Likewise, first you arrange the membership function values. Assign the membership function values. After that, fuzzy terms. Here I utilize the fuzzy terms are low, medium, high. Okay. After that, discrete universe of input membership functions. I consider the input function as a spindle speed. So that I allocate the numerical values because minimum 0 means minimum spindle speed. 1 after that 2, 3, 4 is the maximum spindle speed. Likewise, I allocate the table values with the 0 to 4 numbers. After that, 0. What is 0 value for low? Here you see 0 is available with the origin. Okay. Here how I put 1 means low is started with the triangular initiation point here. Okay. Low. That in that point low value is 1. After that the 0.5 I gradually decrease the triangular function here. It means 0.5 with the medium line. So that I put the next value as like 0.5. After that there is no value available with the 2 here. See 2 the subsequent value is 0. So that I put here as a 0. Then after that 3 there is no value, no low line value available with the high, right? So that I fix 3 as a 0. Similar to same in the area of 4 there are no values, so that I assign 0. After that medium, I consider this medium line only. Initially what happens with the 0 membership function in y axis there is 0, so that I put 0. After that in medium line, okay, medium line relationship with the y axis is 0.5. Can you understand this? Here the one function is available with x axis. After that the nearest value of medium is 0.5. Likewise I arrange. After that 1. How the 1 came for 2? Here you see 2 available. After that medium in y axis there is 1. So that I assign the value 1. Likewise, I arrange the other values 3. Here you see 3. There is no 3 available. I mean medium line available with this. Okay, because it gradually decremented. It does not have any value. So that I assign the 3 0 and also 4 0. There is no medium line available. So that I put like this. Okay. After that high. Here see from low and the medium line only available in initial stage, but high started from 2 where the discrete differentiation, I mean universe number value is 2. So that I started to put the number from 2 universe partitioning. So that 0, 1, 2 or 0, 1 are having 0. After that 2 initial point, according to that 2 there is 0 available. So I assign 0. After that the 2 is gradually increased from x axis. So it meets medium line here according to triangular function. What the associated value with the y is 0.5. So I assign 0.5. After that the high value, the associated value is 1. Likewise I fixed the table. I framed the table according to these inverse partitioning input function values. So I frame the table likewise. Similar to same, I frame the output function table also. With respect to fuzzy terms low, medium, high. According to that discrete universe of input membership function, I assign the value 0 to 4. So that minimum value, minimum thrust force is 0, maximum thrust force is 4. Likewise, I frame the another table which is output membership function. Okay, so the input membership function is partitioned recording minimum and maximum values that allowed controlling the system, which is spindle speed minimum to spindle speed maximum. Based on this, the input membership range is 0 to 4. According to that, our previous tables, I explained how the minimum spindle speed and how the maximum spindle speed occurs. Here you see the value allocated for spindle speed is as follows. 0 is denominated for minimum spindle speed. 4 is denominated for maximum spindle speed. Likewise, the value assigned for thrust force as follows. 0 is assigned for minimum thrust force and 4 is assigned for maximum thrust force. Likewise, I assigned the values in previous tables. Fuzzy relation, then relationship between the fuzzy terms are important. Fuzzy relation builds the relationship between input membership function to output membership function. The relationship established based on the high spindle speed and the low thrust force with the Cartesian product. Okay, so fuzzy rule. Already I fixed the fuzzy rule. Low fuzzy terms and high fuzzy terms with the output function and low fuzzy term with the input function. Likewise, I frame the table. How do I relate the tables? I tell you later. Okay, for rule 1, if spindle speed is low, then thrust force is high. From the universe of output function table, the high fuzzy set is defined as high. So here I frame the values. For membership function 0, in high table there is 0. In membership table function there is 1, I assign 0. In 2 there is 0. In 3 there is 0.5. For high thrust force, and then fourth universe partitioning of thrust force is 1. Likewise, I arrange the values and from the universe of output function table that low fuzzy set is defined as like this, so that I can frame the models likewise. Okay, according to the relationship between high input to low input, how do I form? Here the previous tables explains how do I frame the input membership function and output membership function. Now I go to make a relationship between high input to low input. Where is the fuzzy term input, high input? Here you see, here the high input term is available with the discretization values. So what is the high value with respect to input membership function of spindle speed? Here 0, 0, 0, 0.5, 1. I can pick this value from input discretization table. After that, what about the low output thrust force function? The low values are available here. How do I assign? I pick the values from the previous low, or I mean output table. Here 0, 1, 0.5, 0, 0, 0. Likewise, I assign the values. Okay. After that, how do I make a relationship between high input to low output? Here you see, first 0 with the high. Okay, for the reason in the low 0, 1, universe of output is 0, because I combine 0 and 1, I get 0. And then after that 0, 0.5, I again get 0. After that 0, 0, again 0. Again 0 and the 0, the 0. After that 0 and 0, 0. The product of those two are comes like zeros. What about 1? Okay, so now I consider first, right, low, high to 1. Okay, 0 into 1, 0. 0 into 0.5, 0. 0 into 0, 0. Okay, 0 into 0, 0. Again 0 into 0, 0. Okay, after that, what about the second? Okay, here see second. Second high input is 0 and the low output is 1. So that 0, the product of 0 into 1, 0. 0 into 0.5, 0. 0 into 0, 0. 0.5 into 0, 0. 0.5 into 0, 0. Again, I got the zeros in all respective columns. Okay. After that, I consider third function. There is 0.5. Here you see the difference, 0.5. In low output, there is 1. So that the product of 0.5 into 1 is equal to 0.5. Okay. After that, 0.5, the product of 0.5 into 0.5, there is 2.5 may come, but I consider 0.5 only, because those terms are have equally 0.5, so that I consider 0.5. After that, 0.5 into 0, 0. 0.5 into 0, 0. Again, I got 0 continuously. The final term is 1. Here see the 1. The product of fourth is 1 as the high input and 1 as the low output. So that the product of 1 into 1 is equal to 1. Okay. So I got the inverse of output is 1. 1 into 0.5, there is 0.5. 0 into 0, 0. 0.5 into 0, 0. 1 into 0, 0. Likewise, I make the relationship between high input to low output. After that, the similar to same, I form the tables like this. You may work on note like this. Okay. After that, rule 2. Similar to same, I follow the same procedure for rule 1. I construct the table for rule 2, that is relationship between medium input to medium output. You pick the table column from medium input values from that first table. After that, medium output from the output to membership function table. You relate those things according to our previous table explanation. You follow the thing. You may frame the rule 2 table relationship between medium input to medium output likewise. After that, the rule 3, the relationship between low input to high input. Now you are aware about how do I frame the rule 1, rule 2, rule 3 tables. Okay. After making these relationships, rules combination is the next step. How do I make the rules combination? Here you see the one rule. That's the fuzzy algorithm as follows. Fuzzy algorithm follows the rule combination with like this logarithmic functions, logic functions. Okay, logic functions are, how do I frame the logic function? If spindle speed is high, then thrust force is low. Or I use the or symbol. So or if spindle speed is medium, then thrust force is medium. Again I utilize or function, which is logic function. So if spindle speed is low, then thrust force is high. Similar to same, I prepare the rules combination for my next operation. Here what is R? The R function is one of the operators which are used to represent the maximum of the membership values of the two different relations as follows. Okay, if spindle speed is high, then thrust force is low, or if spindle speed is medium, then thrust force is medium, or if spindle speed is low, then thrust force is high. And likewise, I form the rules combination algorithm. Okay, here the mathematical notation available, mu r1 plus mu r2 is equal to maximum of mu r1 comma mu r2. We will discuss later. Okay, after that, rule combination, which is the next step. How do I combine the rule and rule 1 and rule 2 for thrust force? Here the table, rule 1, relationship between high input to low output available. Rule 2, relationship between medium input to medium output is table available. So I picked those two. Those two tables from previous slides. I frame those tables like this. Okay. Okay. After that, here in 0, 1, 2, 3, 4 is the first terms, and 0, 1, 2, 3, 4 in exact direction there is known as universe partitioning of membership functions. Okay, here what is 0, 0? According to that table, there is for 0, 0, there is 0. After that, here also the second table for the universe partitioning value in fuzzy terms 0 and discrete terms are also 0. So that I finally got 0. According to the combination table, how the both tables are have 0, so that again the combination of 1 and 2 also have 0. After that, the one discrete value has 0, one discrete value in output function is also 0, so that the combination also 0. Then you here see my animation here 0, 0, 0, 0, 0. Likewise, you may arrange the new table, which is rules combination table. The first in fuzzy term 1, okay, 1, 0, 0, 0, 0, 0.5. Here what happens? 0.5. Likewise, you may combine the rule and rule 2 table. In fuzzy terms 1 and the discrete value 1 has 0 in first table. And see the second table, the fuzzy terms 1 is 0. The fuzzy term 1, fuzzy discrete term is 0.5. So I combine and 0 and 0.5. Finally got 0.5. Likewise you frame. After that 0. Again what happens? 0 and 0.5 came. So that again I got the 0.5 in my rule combination table. And then third discretization function is 0. In the output also there is 0. So that the rules combination table also 0. The fourth term is 0, 0. You see, you can easily understand what I do with my tables. Here, second fuzzy terms 0, 0, 0.5. What happens? 0, 0.5. So that again got 0.5. The next is 0, 1. What happens here? 0 in input table and 1 in output table. So that I got 1 in final rules combination table. Okay. Likewise, I frame the rules combination table. Okay, 0, 0, 0. Here you see 0.5 in input inverse table and inverse of output 0. So that the final rules combination table there is 0.5. Okay. Likewise, I arrange the rules combination table with the combination of rule 1 and rule 2. Okay. Here you see, you can understand now how do I combine the table 1 and 2. Here see rules combination of rule 1 and rule 2 for thrust force. Likewise, you write it down with your notebook. Okay, the rules combination of rule 1 and rule 2 for thrust force. Then next step is the thing rule 1, rule 2 and rule 3. Okay, for the with from our previous table explanation, you frame the table rule 1 table, you pick the rule 1 table, rule 2 table and the rule 3 table. For what purpose I pick this table means I frame the another combination, which this combination is combines rule 1, rule 2 and rule 3 for thrust force. Similar to same, you follow the combined combination table of rule 1 and rule 2 table, you frame the rule 3 table. Okay, after that rules combination of rule 1 and rule 2 for thrust force as like our first table. You know the procedure. Okay, after that the combination of rule 1, rule 2 and rule 3 for thrust force, because of our algorithms, fuzzy algorithms, we utilize logic terms or function is or function, so that we combine the things, combine rule 1, rule 2 and rule 3 for thrust force. Finally, we got the table like this. Okay, after that I found the next step is I will find the average value. How do I find the average value, which is the main question. Okay, because up to this time I follow the rules framing and the rules combination. How do I make a relationship between input and output function? Now I aware about, now we aware about. Then next step is find out the average value. How do we find out the average value? Average value is equal to sum of thrust force into mu of s divided by sum of mu of s. Here, what is sum of thrust force? According to our previous table, the combination of rule 1, 2 and 3, there is two fuzzy terms, universe of spindle speed 0, 1, 2, 3, 4 available, and also universe of output there is 0, 1, 2, 3, 4 available. Here you see for universe of spindle speed 0, the universe of thrust force is in 0 term is 0, 1 term is 0, 2 term is 0 and the 3 term is 0.5 and the fourth term is 1. Here you see 0.5 happens with the, I mean 0.5 is happened with the third, okay, and 1 is happened with the 4. So that 0.5 into 3 plus 1 into 4, which is the sum of thrust force into mu of s. So that third term here 3 is the mu of s, 4 is the mu of s, because I next the discrete inverse partitioning numbers 3 and 4. What the value I has in 3 means 0.5. So that the sum of thrust force is 0.5. Sum of thrust force is 1 according to the fourth term available with the fuzzy table. Can you understand this? In third there is 0.5. In fourth there is 1. So sum of thrust force is 0.5. Sum of thrust force according to 4 is 1. So likewise I arrange 0.5 into 3 plus 1 into 4. Here the divided by sum of mu s. Here what happens? In third there is 0.5, in first term there is 1. So that 0.5 plus 1. I calculate these values and I finally get 3.66. Similar to same, I frame the another value, another table, another fuzzy term, there is 1. Here you see how do you frame 1 into 0.5, 2 into 0.5, 3 into 0.5, 4 into 0.5. Now you may aware that, okay, 0.5 is the sum of thrust force value. Here see for 1, 0.5 is the sum of thrust force, so that 0.5 into 1 plus sum of thrust force is 0.5 into 2. 2 is the mu s, 0.5 into 2. Here similar to same, 0.5 is the sum of thrust force into 3. 3 is the mu s. Okay. Finally plus 0.5 into 4. Okay. Likewise, I frame the table. According to that, sum of mu s here is divided by 0.5. You see, according to this table, 0.5 plus 0.5 plus 0.5 plus 0.5. Likewise, I arrange. Based on this, I get 5 by 2 is equal to 2.5. Likewise, you conduct the calculation for finding the average values. What is the final average value of thrust force for specific spindle speed universe is 0, 1, 2, 3, 4. Likewise, I conduct the calculations. From this calculation, I may get 3.66. Here you see, I get 3.66 and also 2.5. Likewise, I frame the another tables also. Sum of thrust force into mu s. Well, how do 1.566 came? According to this table, zero point 0.5, second universe partitioning, zero point 0.5 into 1, 1 into 2, plus 0 into 3, plus 0 into 4. Likewise, I arranged so that 0.5 into 1 plus 1 into 2 divided by 0.5 plus 1, so that I may get 1.66. Similar to same third inverse partitioning, zero point 0.5, for fourth 0.3. Likewise, you may arrange the average value table of that range factor. Why I can calculate range factor? For identifying the new thrust force value, I should conduct the range factor. How do I conduct the range factor? Later you will understand about what is range factor. Here, thrust range factor is equal to thrust force maximum. How do I collect the data with respect to thrust force maximum? Means according to your conducted experiment, what is the maximum value available with the experimental measurement value? I choose that minus thrust force. According to your collected and or measured experimental value, what is the minimum thrust force? You identify that. So that according to my experiment, 98 is the maximum thrust force, minus 63 is the minimum thrust force from the collected experimental data, real experimental data. So that 98 minus 63 divided by average the thrust force of 0. What is the average the thrust force 0 means? It is a partitioning, universe partitioning value 0. For the 0, I got average thrust force is 3.66. So that 98 minus 63 came from my experimental value. Average thrust force I calculated from the table. So that 98 minus 63 divided by 3.66. After derive this, I may get the final thrust force range factor is 9.63 for universe partitioning 0. Next, fuzzy model output. Here you see output for thrust force from fuzzy logic model for titanium using radial drilling machine. According to my experiment, I conduct the titanium as the workpiece material, the HSS tool material on the workpiece, so that my experiment output is in that I consider spindle speed 120, 155, 190, 225, 260. According to the machine tool specification and the standard machine data book, I select these spindle speed ranges. Universe partitioning. Now you are aware about what is universal partitioning 0, 1, 2, 3, 4, because I utilize triangular function for membership function for making a relationship between input and output function, so that here 4 universe partitioning values available. Now you are aware about how do we identify average thrust force? Okay, 3.66, 2.5, 0.33. Likewise, you may now you are aware about how do you identify the average thrust force. Then average thrust force into range factor. Now you are aware about the range factor of thrust force, which is maximum thrust force minus minimum thrust force available with your experimental data divided by average thrust force. So that I get these values. So that I can calculate average thrust force into range factor. I may get these values. Finally, how do I get the final thrust force output value? Here I sum average thrust force into range factor plus minimum thrust force available with my experiment. According to my experiment, the minimum thrust force is 63. So that I add 63 plus 35.25, I got 98.5. You see, according to my experiment, 63 is the minimum thrust force. So I add 63 plus this 35.25, I may get the maximum, real thrust force values 98.25. Likewise, the first inverse partitioning, there is average value thrust force into range factor is 24.08. I add this into minimum thrust force. I got 87.08. Likewise, I add all the minimum thrust force available with a combination of average thrust force into range factor. I got new output of thrust force. Okay. Why I conduct this experiment? Why? Rather than design of experiment means, here you see 120 spindle speed available, 180 spindle speed available, 260 spindle speed available. What about the thrust force of 130? What about the thrust force value may occur with 190 spindle speed? Without the experiment, I can examine, I can test with this fuzzy logic model, because 120 available, 180 available. What about the intermittent value? I can find through this considered fuzzy logic terms. for 120.02 the experimental is 98, 180.02 the feed rate is 49. Likewise, I collect the data with the calibrated measuring instrument and the calibrated experimental setup. Okay, from this, compare these all the things here. My experimental data 98 is the maximum value and 63 is the minimum according to 120 spindle speed and the 0.02 feed rate. So that I choose these values. Okay, I frame the newer output from thrust force. I mean from the fossil model is values are these values are tabulated. I compare the developed fuzzy model with the experimental. Generally, how do I consider calculate the percentage of deviation? Means first you collect the original data, which is experimental data minus fuzzy logic model data divided by original data into 100, which is prescribed by previous journal. So that I follow the formula. Experimental data is the standard one. So that experimental data minus predicted, which is fuzzy logic model 98 minus 98.3 divided by original value, which is experimental value 98 into 100, I got 0.3. Likewise, I summarize all the percentage of deviation values with the fuzzy logic model and the experimental model values, so that I get these kind of deviations. Okay, so average deviation, which is also important, average deviations I got from fuzzy model is 24.5. So I got less than 30 percentage of deviation according to my experiment. Okay, after that I plot the graph. You may represent the graph with the journals and your thesis report. Other things you mention the things with the graphical format is suitable for your presentation. So I present the table, I mean graph also. Comparison platform, experimental and the fuzzy logic values of thrust force. Okay. After that, the inference I like results. Fuzzy model generally needs rule evaluation based on experimental of or experts knowledge. Already I told you how do I frame the rules. Okay, how do I frame the rules? If spindle speed is high, then thrust force is low, or otherwise if spindle speed is medium, the thrust force also medium. Based on the experience only, I can get the knowledge and I can frame the rules. The fuzzy models were developed based on fuzzy rules. So the fuzzy models generally frame based on the developed fuzzy rules. Here, according to this problem, spindle speed is the input and the thrust force is the output. The fuzzy logic predictive models were compared on the basis of their prediction. Okay, after that the models were validated with 9 data sets. I conducted the experiments with the design of experiment concept, so that I follow L line orthogonal array, so that I got 9 data sets. From that I picked the values and solve the problem with the fuzzy logic model, which is artificial intelligence technique, one of the artificial intelligence techniques. The predicted values of thrust force were compared with the corresponding experimental values. Finally, I got the difference between the predicted values of fuzzy model and the experimental value is very small, so that I can utilize this model for further investigation of thrust force to the conducted experiment and developed fuzzy models. Thus, the fuzzy logic model can be used to predict the thrust for any combinations of drilling parameters within the range of experiments. I can't utilize this model for beyond my consideration of input levels and output levels. Within the input levels, I can utilize this model for further experimental evaluations. Okay. Okay, thank you. Any queries, you may ask me with the comment box. Okay. How do I conduct the experiment? Already in my previous video shares you how do we conduct the experiments with the design of experiments. How do we conduct the data analysis? You may refer my previous videos. This video is helpful for conduct the experimental analysis with the intelligent techniques. Okay. Thank you all.